Hello, today I'm going to be explaining what insulators and conductors are. Insulators and conductors explained. Number 1. Introduction. Heat transfer basics. Before we talk about insulators and conductors, we need to understand how heat or thermal energy moves. There are three main ways heat transfers. Number 1. Conduction. Heat moves to a solid material. 2. Convection. Heat moves through fluids, liquids, or gases. Radiation. Heat travels in waves, like sunlight. Whenever there is a temperature difference, one side hot, the other cold, heat naturally flows from hot to cold until both reach the same temperature. Number 2. Thermal conductors. A thermal conductor is a material that allows heat to pass through it easily. Examples: metals, copper, aluminum, silver, iron, some rocks or ceramics. Why conductors pass heat easily? In metals, the atoms are tightly packed and free electrons move easily. When one part of a metal gets hot, the fast-moving electrons carry energy quickly to the cooler parts. That's why if you heat one end of a metal rod, the other end soon becomes hot. Everyday examples. Cooking utensils made of steel or aluminum conduct heat from the stove to the food. Radiators and electric kettles use metals to transfer heat efficiently. Number 3. Thermal insulators. A thermal insulator is the opposite, a material that does not allow heat to pass easily. Examples: wood, plastic, rubber, styrofoam, wool, fiberglass, air and vacuum. Yes, air itself is a good insulator. Why insulators stop heat? In insulators, the particles are not free to move easily. There are no free electrons like in metals. Heat moves slowly because the vibrations of atoms take longer to pass the energy along. Everyday examples: clothes and blankets trap air to keep you warm. Plastic candles and pots prevent your hand from burning. House insulation keeps room warm in winter and cool in summer. Number 4. How conductors and insulators relate to temperature. When we talk about conductors and insulators in terms of temperature, we mean how fast a material can equalize its temperature with surroundings. A conductor quickly reaches the same temperature as its environment. If you touch a metal spoon and a wooden spoon in the same room, the metal feels colder, not because it's really colder, because it conducts heat away from your hand faster. An insulator stays at its own temperature longer because heat doesn't flow easily through it. So, conductors help in transferring heat, while insulators help in maintaining temperature. Number 5. The thermos, vacuum flask. Now let's bring all of this together. A thermos or vacuum flask is designed to keep hot things hot and cold things cold by stopping heat transfer. It's one of the best everyday examples of combining insulation and reflection principles. Structure of a thermos. A typical thermos has one inner container holds the liquid made of glass or stainless steel. Number 2. Outer shell, protective casing. Number 3. Vacuum layer, space between the inner and outer walls. Reflective coating, usually silvered on the inside surfaces. Tight lid or stopper, usually plastic or rubber to prevent air exchange. How each part works. Let's look at heat transfer method and how the thermos blocks it. Number 1. Conduction. The inner bottle is separated from the outer shell by a vacuum layer. Since vacuum has no particles, heat cannot conduct through it. The neck and the lid, the only contact points, are made of plastic, which is a poor conductor. Result? Hardly any heat travels by conduction. Number 2. Convection. Convection requires air or liquid movement to carry heat. The vacuum layer again stops this because there is no air in it. The tight lid also prevents air from circulating inside the bottle. Result? No heat loss through convection. Number 3. Radiation. Radiation travels as electromagnetic waves, like sunlight. The inner surfaces of the thermos are silvered or mirrored, so they reflect infrared radiation back toward the liquid inside. This prevents heat from radiating away if it's hot, or from coming in if it's cold. Result? Very little heat transfer by radiation. Number 6.